So first, Alice and Bob use error correcting code. Let's call it C, to make sure they agree. And how do they do this? Well, Alice has a string of bits B, and Bob has a string of bits B plus E. And we'd like this E, we'd like this somehow to turn it into correcting an error with an error correcting code. So Alice chooses random C in C. So she chooses a random code word in C, and she computes B plus C and sends this to Bob. And Bob can now, and I want to say Bob adds B plus C and B plus E. Let's just write this out. Equals C plus C. So Alice has C. Bob, well, this is a error correcting code with a small error added. We can correct it. So Bob computes C. And now what does Bob do? Well, Bob has B plus E. He has C plus E, and he has C. If you add all those together, you get B. C plus E plus C is equal to B. So Bob can get Alice's bit string from Alice's bit string. And what did Alice do? She took a error correcting code and added a random bit in the error correcting code to get to B to get C. So I want to claim that doesn't leak any information to Eve. Or rather, it does, but it doesn't leak very much. So basically, it leaks the coset of C that B is in. So let's say C is true to the K code words. They still have K random bits. Because they agree on C, and C is in the code, so they have 2 to the K possible messages. So maybe I should have said Bob can compute C, and Alice knows C, so maybe C is their random string. Okay. So they agree on one of 2 to the K messages, and because B was totally random, B plus C doesn't tell anything to Eve. Rather, it tells her what coset of C B is in, but it doesn't tell anything about which code word in our error correcting code they agree on. So you still have K random bits because they agree on a code word in C.